Hello and welcome to another installment on the Run on Requirements YouTube channel. This is on a slightly different topic. This is a paper that I gave in 2013 at the International Council on Systems Engineering Symposium in Philadelphia on systems engineering and the Agile methodology. Agile had become quite the buzzword, and everybody was interested in doing it, and people were talking about Agile systems engineering. And so I put this together at the time to discuss when it might be appropriate. I'm recording this now in 2024 because this topic keeps coming up. Particularly, there was a posting in LinkedIn about the death of the waterfall development model, and I pointed out a couple of my observations, so I thought I'd record this and post it as well. Also, this paper was referenced in the 4th edition of the INCOSE Systems Engineering Handbook, but it is no longer referenced in the 5th edition, so I thought I'd make it available to people who are interested. So, can systems engineering be agile? And to talk about the development life cycles for systems, hardware and software, and when the use of agile may be appropriate. So what I'm going to talk about is the Agile principles that have been published many years ago, talk about when Agile methodology might be suitable, discuss differences in systems engineering and software engineering processes, system engineering as a gated process and Agile software engineering as a continuous validation process, and some of the additional key differences, and then conclude with a discussion of suitability. So the Agile principles, and they're available on the internet in the manifesto. The emphasis is on getting to the end state very quickly versus the process. They talk about working software versus comprehensive documentation. This did arise in the software domain, and that is where it has found wide applicability. And so the question is, can this be extended? Can these principles be extended to systems engineering? And so that's what I'm exploring in this paper. I listed on the left some suitability factors that one might consider for the applicability of any particular method. And in this table, I've described Agile methodology, plan-driven, which is a reference to the Boehm and Turner book in 2004 called Balancing Agility and Discipline. And some of this material comes from that. I've also added a column for formal methods, and a reference is there. This the written version of this paper is available in the Wiley and INCOSE library, free for INCOSE members. So going down the factors here, depending on the criticality of the software, Agile methodologies most applicable for low criticality, internal development, websites, that sorts of thing. Plan-driven is the traditional approach to systems engineering when you have high criticality, when you feel like you must get it correct the first time, and you may not have the opportunity for iterations. Formal methods for extreme criticality, which means you have to know the behavior of what you're producing under all conditions. Personnel identified senior developers for Agile and formal methods, and systems engineering is more process driven, and so it's suitable for junior developers because of the rigor in the serialized processes. A suitability factor of dynamism, how often things are changing. Agile is most suited for that. And in fact, that's one of the reasons it's very, very helpful. If you're not quite sure what you're doing, then you do something and put it out there and see if the users like it. You can change very quickly. Plan-driven and formal methods are not so amenable to dynamism. You can manage change, but it's a managed change, and it can have a significant impact. Suitability factor of size. Agile describes itself as suitable for a small number of developers. Plan-driven traditional systems engineering is very suitable for large numbers, tens of thousands of people working in parallel. And that's where it actually arose in the, you can go back to the 30s or the 50s or the 60s, depending on whether you want to talk about the origin in AT&T in the US or the missile programs in the US, but tens of thousands of people working in parallel. And that's one of the key features of traditional systems engineering. Formal methods are more suitable for small numbers of requirements and people where the system can be modeled rigorously. Last suitability factor listed is culture. And Agile is suitable for a culture that thrives on chaos. Doesn't matter if things are topsy-turvy on a regular basis. Plan-driven is not so suitable for that because it's a culture that demands order, and you'll see that in the discipline. Formal methods is more extreme in that, demanding rigorous modeling and extreme quality. So these are some of the suitability factors related to when to use one or the other of the methods. In particular, systems engineering is an integrated gated process in accordance with the standards. We do something and then we finish it and we do something else. And between these life cycle stages, which is the description in the NCOSE SE handbook and the international standard, we have gates. These are decision gates that include reviews, both vertical, in other words, up and down the totality of the architecture, and horizontal across all elements of the system definition at that stage of development. And this is to ensure a holistic and consistent design before we build, to ensure that all stakeholder requirements are addressed and being satisfied, and that all elements work together to satisfy the stakeholder requirements. And because of this, the discovery activity of what is needed is primarily allocated to the requirements phase. So if there are additional things that arise, say discovery and verify, that's considered not a good thing. We want to discover all the requirements and all the solution constraints up front so that when we design and build, we minimize the large feedback loops back to requirements and design. Validation is continuous in ensuring that we have the right set of requirements to meet the needs, we have the right design to meet the needs, and we have the build capability, and we have the build process, and we build whatever the items are that will meet the needs and so forth. And then at the end, after completion of verification, we have an operational validation in use or in the marketplace. In contrast, Agile software development is built on the idea of continuous validation, following the user and getting regular feedback from the user, the primary stakeholder, regarding the suitability of the delivered software. Working software can be immediately releasable. There's no additional manufacturing or production lifecycle stage. It can just be built. And another feature is that the designer may be the builder. In other words, the same person designing the software is maybe writing the code. So the need for documentation between design and build is minimized. And in fact, the software development can adopt a finish-to-finish strategy where you build it first and then put it in use to confirm the user satisfaction and iterate on that cycle of build and integrate. And only later might you need to do additional documentation of, well, what did we finally end up with as requirements, and what is the documented design, and adding comments to the code and so forth. Subsequent builds on top of the first one are assumed to cause little rework. In other words, it's additive, it's incremental, and the end state is not necessarily known when it's begun. And that may be okay because most of these activities can proceed in parallel once the code is finished. And the Agile Manifesto says they emphasize working code over documentation. At some point, someone's going to need documentation for lifecycle maintenance. But the documentation can happen later, especially if the builder of the code is the designer. So we document and verify as needed, and this finish-to-finish strategy enables rapid change, because when we get feedback that says we want some improvement or some modification, we don't necessarily have to go back through requirements and design. We can jump to build and integrate and validate. So those are some features of Agile software development. So to summarize some key differences, discovering what users want, what users value in system engineering, it's upfront, it's formal, it's documented, there'll be incremental updates, but it is always documented. Whereas in Agile software engineering, it's a process of continuous discovery and refinement. On the subject of collaboration, who's doing the development? Systems engineering assumes that there are going to be independent and parallel development activities by many people in different organizations. There may be one acquirer, but many suppliers. And so it's not reasonable to expect that users are going to be able to support all those different organizations continuously. Agile software engineering assumes that there is strong and continuous user collaboration with the supplier during development, and this can be a substitute for getting upfront requirements by eliciting from the user what it is they want and what they want changed as each element of the solution is delivered. In particular about requirements, how are they defined and refined in systems engineering? We begin with the concept of operations and the stakeholder values and measures of effectiveness in order to derive functionality and requirements at all architectural levels. In Agile software engineering, they talk about user stories and test-driven development. But the idea is we understand what is it the user wants, and then the software is built to that. And then the users validate what has been produced, and user stories and test definition may be modified accordingly. A key difference is who's building the solution, meaning translating the design into reality, going from development into implementation. For systems engineering, it's assumed that the builder is different from the designers. So order is critical, and the documentation has to be sufficient to be able to implement the design as it's defined. Whereas in Agile software engineering, the builder may be the same as the designer. In other words, the person writing the code is the one who designed that module of software. So the order is less important. So when is Agile suitable? These are my observations and suggestions. Well, Agile may be suitable for internal development within an organization or exploratory development. Plan-driven traditional systems engineering seems more appropriate for contracted development for anything other than time and materials type of work, and similarly for formal methods. The contracting approach I just mentioned, Agile is very suitable for time and materials because the acquirer is purchasing from the supplier their time, and it's really up to the acquirer, representing the user, to do a good job of managing how they are using their supplier's time. So if they want to rework and iterate on a regular basis, that's okay. Plan-driven is more appropriate, especially for fixed price. You would, in my mind, you would never want to go on a fixed price contract in an agile environment where the acquirer is not sure of what they want at the end, and they'll tell you along the way. Similarly, formal methods are more suitable for fixed price or cost plus type of contracts. The key managed risks are different. For Agile, the key risk is time to market. We want to get something out there, and we also want to avoid user dissatisfaction, which is why user engagement is critical. Continuous user engagement is critical. That may run afoul of short time to market if it causes rework, but that's what we're attempting to manage. Plan-driven methodology, we're most concerned about contract breach and rework. In other words, we have a contract from an acquirer to a supplier. We want to make sure we satisfy that. Any changes that are needed are subject to contract change. And so the focus is on avoiding rework by staying aligned with the original requirements and using managed change of any activity by formal change processes. In formal methods, the main risk we're trying to manage is unexpected behavior. So all potential conditions imposed on the system have to be examined and dealt with in the solution. The role of the stakeholders in Agile, it's assumed there's a full-time on-site user. So this is why this may be appropriate for internal or exploratory development. In plan-driven traditional systems engineering, we have upfront systems engineering by a customer or user, at least we hope there is some. That's extended down into the suppliers then. But there's periodic validation and ultimately operational evaluation by the users or their surrogates. Formal methods, similarly, there's upfront systems engineering by all the stakeholders, periodic validation, and continuous verification that the solution being built is robust under all conditions, and ultimately an operational evaluation. User needs statements are described in Agile as capabilities or user stories. They may be incomplete, but that's okay, because that can be continuously updated. In plan-driven systems engineering, we begin from the concept of operations and develop from that lifecycle concepts, stakeholder requirements, and ultimately system requirements. Similarly, in formal methods. Planning and analysis for Agile, there's some planning of the overall scope, but it's focused on short work projects, sometimes called sprints, planning for those, and then when those are completed, then there's some more planning. So it's sequential in that way. Plan-driven systems engineering requires extensive planning, end-to-end planning through development, and in parallel planning for production with significant some analysis along the way. Formal methods has extensive analysis using model-based methods so that they know with a full simulation of what they're building that will actually do what's needed and will handle all possible conditions to be imposed. So the primary domain of applicability for Agile, it's software. For plan-driven systems engineering, it's everything. For formal methods, it's been mostly applied to critical software and hardware. And finally, the fabricator, the one who is building it. In Agile, as I said, it may be the same as a designer. In plan-driven systems engineering, it's typically independent of the designer, and that's why we have drawings and other similar artifacts. In formal methods, what they've gone to is code generation from a formal language. So the fabricator is actually the machine based on the formal design. So those are some suitability considerations for selecting one or more of these approaches. So what would agile systems engineering look like? Well, it would be, in my mind, be characterized by an ability to create vertical slices of capability incrementally. In other words, we don't immediately implement all of the system requirements. We do some of them. But what this requires is that at some point, you have to decide that you may discover what are called architecture breakers. That's a Bayman-Turner term, where you have to rebuild elements of the system. You may, for example, find out you have the wrong hardware once you get to the last set of requirements or some increment of requirements. In software development, it's called refactoring. That's a rework term, but it's more significant when there's hardware involved if you haven't gotten the right hardware to start with. So this is the biggest risk in applying systems agility, agile methods to systems engineering, considering hardware, things like computers and networks, where if we haven't upfront defined the correct items that will ultimately be able to support the totality of the system requirements, we have to rebuild things, redesign, re-architect, rebuild. And of course, that's going to introduce a lot of programmatic rework. So that's the biggest risk of the concept of agile systems engineering. If you can assume stable hardware, in other words, that there is no possibility that the hardware will need to be rebuilt, then it turns the system engineering activity into a software development activity, and it may be appropriate to use agile methods. But this is what we're considering when we think about agile systems engineering. I incrementally add vertical slices of capability from the top system requirements all the way down however many 2, 3, 6, 8 levels of the architecture to realize that additional requirement that is being implemented in a specific increment. So enablers for agile systems engineering, first, contracting by other than a specification. So I mentioned time and materials as an approach, because the specification basically declares that here is the complete set of requirements for the supplier. Another enabler is decreased subsystem coupling, loose coupling among system elements, with the hope that incremental changes only affect a very limited number of the elements of the overall system. Another key enabler is reduced hardware and system fabrication cycle time, and additive manufacturing or 3D printing is going to be a big contributor to this. Also, continuous integration of changes, getting the life cycle of integration verification timeframe down so that when changes are made, they can be implemented very quickly. The last thing is a stable infrastructure for things that take a long time to change. So if different elements of hardware, especially, are not amenable to rapid change, then they have to be stable no matter what happens with the rest of the functionality. So in summary, I would say some of the unique features of typical software development enable the benefits of agility, continuous discovery, and rapid update. You know, if you find a problem, you can fix it overnight and release the updated software that next day, or even the same day. So that is a benefit of some of the capabilities in software development, but most systems, unless they're purely software, do not have that short cycle time. Agile systems engineering carries additional development risk in horizontal integration. We talked about the architecture breakers, the risk of volatility, due to additional user involvement, especially over long development cycles, the stakeholders may change, and the new stakeholders or the revised users may have different ideas of what is wanted. And so what seemed a good idea earlier may no longer be considered a good idea. There's risk in not seeing the whole integrated ultimate design, which can lead to more rework when that is finally discovered. So systems engineering is in place to manage these risks, and the implementation of agile systems engineering just adds risk in these specific areas. So I hope this was useful and helpful, and whatever methodology you choose, always consider the risks associated with your planned approach so that you can deliver what needs to be delivered according to whatever commitments have been made. So thank you for your attention. I wish you all the best.